So far, we have learned solving by graphing. But it's not always easy to graph. So we're going to learn a new method to solving systems of equations, and that method is called solving by substitution. So I have two equations and two unknowns, x and y, and then I have my two equations, x equals 1 plus y, and 3x plus 5y equals 11. So I know that x is 1 more than y, and I know that 3x's plus 5y is 11. But I'm going to solve this without graphing. The method I'm going to use is called substitution. So far all we've been doing is substituting numbers for variables. But now we're going to be substituting expressions for variables. So in the top equation, we know that x equals 1 plus y. So I'm going to put a little box around 1 plus y because that is what x equals. So now what I'm going to do in my bottom equation is substitute in 1 plus y where I see x. Because that is what x equals. So I'm going to rewrite this equation, but instead of writing 3x, I'm going to write 3 and then 1 plus y. So I rewrote the second equation, but instead of writing x, I wrote what x equals. The reason I did that is now I have one equation with one variable. And if you have one equation with one variable, you can solve. And so the box is just like a parentheses. So I can distribute. 3 times 1 is 3. 3 times y is 3y. Bring down the plus 5y equals 11. Then I can combine like terms. So that's 8 y's. Then to solve, I'll subtract 3 on both sides. 8y equals 8. Divide both sides by 8, and y equals 1. So with one equation and one variable, I can solve. Now that you know what y equals, you can substitute that in to either equation and solve for the other variable. Now I'm going to use the equation that I have denoted up here, because x is already by itself. And x is what I need to know to finish the process of solving, because to solve a system, you need the ordered pair. You need the x and the y values. So x equals 1 plus y. So y is 1. That's what I found right here. So x equals 2. So my ordered pair, my solution, is 2, comma 1. X is 2, so y is 1. Yes? Now, you guys want to check your answer? So does 2 equal 1 plus 1? Yes. And if we plug in 2 comma 1, does 3 times 2 plus 5 times 1 equal 11? Yep. Good job, you guys. Yep. 6 plus 5 equals 11. So we got it. So that is solving by substitution. You substitute one variable's expression in for the other equation, and then you solve. Want to try again? So we have y equals negative 3x plus 5, and x plus 2y equals negative 10. You'll notice in the first equation that y is solved for. Solved for means y is all by itself on one side of the equation. So I know what y equals. Y equals negative 2x plus 5. So I'm going to take y and substitute it into the other equation. Then I'm going to rewrite that equation with y substituted in. So I write x plus 2, but instead of writing y, I'm going to write what y equals. Negative 3x plus 5. And then equals negative 10. Now that box is just like a parentheses, so I'm going to distribute. So I get negative 6x plus 10. I'll combine like terms. One x plus negative 6x is negative 5x. I'll subtract 10 on both sides. Negative 10 minus itself is negative 20. Then I'll divide by negative 5. Negative divided by negative is a positive. In this case, positive 4. Now, since you already have y solved for in that first equation, that's going to be the easiest one to substitute into. So we know x is 4. So I'm going to rewrite this equation. Y equals negative 3 times x. But we know what x is. X is 4 plus 5. So y equals negative 12 plus 5. Y is negative 7. So now we have our ordered pair, 4, negative 7. Any questions? Then we can check, make sure it works. Does negative 7 equal negative 3 times 4 plus 5? And does 4 plus 2 times negative 7 equal negative 10? Yes. It does. 4 plus negative 14 equals negative 10. Oh, yeah. I'm so confident. You're right. You're right. Okay. All right, I want you to do this one on your own. Here, I'll minimize it. There you go.
Thank you. Okay, so I'm going to use x minus 4 to substitute for y because y equals x minus 4. So then I write out x plus x minus 4 because you don't want to put y again. That makes no sense. And then you equals 12. And then x plus x is 2x minus 4 equals 12. And then we're just going to solve. So then plus 4 on both sides. Sorry, and then divide by 2 on both sides. X equals 8. So now that you have x, I'm going to do this difficult.
It's up to you.
Okay, so now we're going to solve for y, and we know y equals x, which is 8 minus 4, and then y equals 4. So then your little order pair would be 8.
Any questions?
Any questions?
Now, I knew threw you guys for a loop a little bit that it didn't have a number in front of there, but you guys good questions or you can handle it. All right, let's take a look at this one.
Oh, yeah, number. Would you do it like you would do, if you would do like y equals, and that's what you do and you go, so then you can have y equals. So would you do that?
So you want to solve for y?
Yeah, because why not? Why
not? Yeah, do we have to solve for a variable? Okay, can we substitute without yes, go ahead, CJ.
All you have to do is solve, like, for one, right? Like, get one variable alone for one of them, and then plug it in.
Okay, so you have to solve for one of the variables. Amongst the variables, we have 2 x's and 2 y's to choose from. Which looks easiest to solve for in this problem? Davian? The second y. So let's get y by itself in the second problem. So you have a negative 4x, so let's add 4x to both sides. But you can solve for either of the variables. Doesn't have to be y, but in this case y is easiest. So we get y equals 4x minus 8. So that's what y equals. Now, you use the second equation already. So you're going to substitute in for y in the first equation. Right here. So I'm going to recopy the first equation. 2x minus 3y. Instead of writing y, I'm going to write 4x minus 8, what y equals. And that is 9. Now, when you distribute, you're distributing a negative 3, not a 3. All right, now, combine your like terms.
Yeah.
Subtract 24 on both sides.
Then, okay, so I can't. Yeah.
I'm going to call it 1.5. You could also call it 3 halves or 1 and 1/2. Okay. So now you might be asking yourself, where do you want to plug this in to find y? Because you can plug it in a number of places, maybe.
Plug it in with y equals 4. Let me see.
Yes, this is the absolute fastest place to plug it in. Now you could plug it into the top equation, the first two equations, the ones you were given, but it'll just take you a little longer. This one y is already solved for, so it's easiest to use it there. All right, so take a look. I plugged in 1.5 for x, and now I don't have to solve anything. Y is already by itself. So I get y equals -2. Okay, so if you find an equation where one of the variables is not solved for, you have to solve for it. Any questions on that? What if none of the variables is easy to solve for? You just do it. You just have to pick one. What do you think? What should we solve for here? Y. Yeah. It won't always be y. It could be x. But let's solve for y up here. All right, so now I have solved for y. Let's see what happens when I plug it in. 6x minus 9 equals -3 times y, which is -2x plus 3. Stay tuned, people. This is going to be interesting. So if I distribute here, I get 6x.
Oh my gosh.
Sorry.
I'm shook.
Okay, so if you were trying to solve, you get all the x's together, right?
I am shook. I am shook.
How many x's do you have?
0.
So you get -9 equals -9. Now, is this a true or a false statement?
True.
This is true. So if you do all the things and you get a true statement, that means there are infinite solutions.
What? I am shook.
Now, freshmen, graphically, what does it look like when you have infinite solutions? On the same line. This was the same line. If you were to put them both into slope-intercept form, they were the same line. If you were to get a false statement, there would be how many solutions? 1. No solutions. And that means the lines would be parallel. So sometimes it's not going to work out how you think it is. All right, here's your assignment.